Is the universe infinite? It's one of the most compelling questions you could possibly ask. One that humanity has been asking since basically the beginning of time. What's beyond the known limits? We've known for some time now our universe is expanding, and in recent years discovered this was happening considerably faster than we'd expected. The observable universe is still huge, but it has limits. That's because we know the universe isn't infinitely old. We know the Big Bang occurred some 13.8 billion years ago. That means that light has had only 13.8 billion years to travel. It also means we don't know with any certainty what shape the universe as a whole takes, whether it's a closed cosmic doughnut, a flat plane that stretches out like an endless piece of paper, or a giant sphere in a state of constant expansion. This has left scientists wondering about the furthest reaches of space and what they may look like. In 2014, when astronomers added ultraviolet data to the Hubble Ultra Deep Field, they were able to study some of the youngest, largest, and hottest stars located between 5 billion and 10 billion light-years from Earth, ultimately finding that young galaxies grow by forming small groups of very hot stars. In this deep portrait of the universe, we see roughly 13 billion years of cosmic history. So we know the age of the universe is finite, at least from the time of the Big Bang. But the universe is getting bigger. It has been expanding in all directions ever since the Big Bang. Measurements taken by satellites have pointed to the universe having a flat geometry. In a flat universe, two light beams shot side by side through space will stay parallel forever, and will never cross or drift apart. In this sense, we can still think of a cylinder or torus, doughnut-shaped universe as being flat. Current measurements aren't accurate enough for us to know whether the universe's flat geometry is represented by a piece of paper, a cylinder, torus, or any other shape that permits the parallel passage of two beams of light. An infinite universe could have a geometry that is totally flat like a piece of paper. Such a universe would go on forever and include every possibility, including endless versions of ourselves. On the other hand, a doughnut-shaped universe would have to be finite, as it's closed. But for now we still don't know the shape of the universe, and therefore nor can we know its size. Despite this, astronomers can still set some limits on what must be true based on the observations they have collected and refined over the past century. Using today's most powerful telescopes, astronomers see galaxies located over 13 billion light-years from Earth. A light-year equals about 6 trillion miles, or 10 trillion kilometers. Since they see these distant galaxies in all directions, the current horizon of visibility is at least 26 billion light-years in diameter. But the universe is probably much larger than the portion we can see. Here's where it gets weird. If inflation happened, then it may have occurred in many places, perhaps an infinite number beyond the visible horizon and the limits of the space-time continuum we are familiar with. If this is so, then other universes might exist beyond our ability to detect them. But even if the universe is finite, it doesn't necessarily mean there is an edge or an outside. It could be that our three-dimensional universe is embedded in some larger, multidimensional construct. That's perfectly fine and is indeed a part of some exotic models of physics. But currently, we have no way of testing that, and it doesn't really affect the day-to-day operations of the cosmos. The universe doesn't need that outside perspective in order to exist. The universe simply is. It is entirely mathematically self-consistent to define a three-dimensional universe without requiring an outside to that universe. When you imagine the universe as a ball floating in the middle of nothing, you're playing a mental trick on yourself that the mathematics does not require. For now, it's wondrous enough to know we live in a universe that's at least 550 billion trillion miles across, and it may be much bigger than that.